Hey guys, so we're going to talk about Avogadro's law today. So Avogadro's law, remember Avogadro's theory, Avogadro's hypothesis from when we were learning moles, okay, is a principle stated in 1811 by the Italian chemist Amedeo Avogadro that equal volumes of gases at the same temperature and pressure contain the same number of molecules regardless of their chemical nature and physical properties. Okay, remember that this number, Avogadro's number, is 6.02 times 10 to the 23rd. It is the number of the molecules of any gas present in a volume of 22.41 liters and is the same for the lightest gas, which is hydrogen, as for a heavy gas such as carbon dioxide or bromine. Okay, so basically, in other words, his principle is that equal volumes of all gases at the same temperature and pressure contain the same number of molecules. So thus the volume of all ideal gases at STP is 22.4 liters. Okay, and then when you put that into formula form and find out what the relationships are, this is the equation that we'll get for Avogadro's theory. V1 over N1 equals V2 over N2, where V is the volume of your gas and N is the amount of substance of gas, or the amount of your gas particles. Okay, so this is a representation of that law. So again, he was saying that if you have the same volume, okay, and we have different gases, helium, oxygen, nitrogen, they're all at the same temperature, they all have the same pressure, it does not matter. They are going to have same volume, same number of molecules, 1 mole, 1 mole, 1 mole. Okay, they are all going to have the same volume. Okay, same volume, same number of moles. It doesn't matter what kind of element of gas you have. Okay, so guided practice, calculations. So example number 1, 5 liters of a gas is known to contain 0.965 moles. If the amount of gas is increased to 1.8 moles, what new volume will result at an unchanged temperature and pressure? Okay, so if we take a look at our variables, we have volume, so that's going to be our initial volume, and it's known to have 0.965 moles. That's going to be our initial number of moles. Okay, and then it's telling us that the number of moles increased to 1.8. And then our volume, what is our new volume? So if we plug in those givens into our formula, we should get something that looks like this. Okay, so 5 liters divided by 0.965 equals V2 over 1.8 moles. And then remember, when we have a fraction like this, the best way to solve is to go ahead and cross multiply. So we're going to multiply 5 times 1.8, and then we're going to divide that by 0.965 moles. And we should get an answer of 9.326, which rounded to the correct number of significant figures is 9.33 liters. Okay, and then also, if you have been watching some of these videos, a good way to check yourself is to look at the relationship between volume and numbers of moles. Okay, remember, if we increase the number of moles we have, we should expect to increase our volume. They have a direct relationship. If one goes up, the other goes up too. Okay, so if we decrease the volume of our container, so if we have a balloon and we let that air out, what can we expect to see in the number of moles in the balloon? We should expect the number of gas molecules to decrease. Okay, so if our number of moles is increasing or adding more molecules, okay, we could expect to see the same for our volume. If we're adding more molecules, we should expect our volume to also increase. Okay, so that's also one way to check to make sure that you're doing these calculations correctly. Okay, it applies to Boyle's law as well as Charles's law. Okay, so moving on to example number 2, if you want to try this one on your own, go ahead and pause. But example number 2, a cylinder with a movable piston contains 0.005 moles of helium at room temperature. So more helium was added to the cylinder and the volume was adjusted so that the gas pressure remained the same. So how many moles of helium were added to the cylinder if the volume changed from 2 liters to 2.7 liters? Okay, and then we can assume that temperature is held constant. Okay, so again, if we look at our variables, our initial number of moles is 0.005, and then our volume increased from 2 to 2.7. So if we plug in those variables into our equation, into our formula, we're going to have 2 liters divided by 0.005 moles, and then equal to 2.7 liters over our unknown number of moles. Again, we cross multiply when we're given fractions. So we'll get 0.5 times 2.7 and then equal to 2 liters times N2. Okay, we multiply these two values and then we're going to divide by 2 liters and we would actually get 0.00675. So our final answer is 0.007 liters. And again, check your work. Okay, we have a direct relationship. Remember, Boyle's law is linear. It's P1V1 equals P2V2. It's kind of like a line. Remember our example to help you remember Boyle's law was a seesaw. For Charles's law and Avogadro's law, they're both in fraction form. And if we try to make a box around that, it's like an elevator. Okay, so if volume goes up, number of moles goes up too. So if our volume increases from 2 to 3, we have more space. So that means that the number of moles was increased. We put more gas in there. Okay, so that actually concludes our notes today for Avogadro's law. If you guys have any questions, please leave a comment or ask me in class. Have a good one.